The deep ocean has always felt like the last true frontier on our own planet. It's a realm of constant darkness, near freezing temperatures, and absolutely bone-crushing pressure. For a long time, we looked into that abyss and pictured a barren, empty desert. We figured that 7 miles down, at the very bottom of the world in the Mariana Trench, the pressure is so extreme, about 1,100 times what we feel at the surface, that complex life was simply out of the question. We thought it was a silent, empty void. It turns out, we were wrong. Recent expeditions, pushing the boundaries of technology, have sent robotic explorers into the Challenger Deep, the trench's deepest point. And the data they've sent back doesn't show the wasteland we expected. Instead, they've returned with images of remarkable creatures, evidence of unexpected biology, and proof of a brand new, unique ecosystem thriving in the dark. We went looking for the very edge of where life could exist, and instead, we found a whole new chapter. The story of life on Earth is being rewritten, and the newest pages are truly mind-bending. The journey down to really get what we've just found, you have to appreciate where we had to go to find it. Picture a journey straight down into the Pacific Ocean, to a place deeper than Mount Everest is tall. Our trip begins in the world we know, the sunlit zone. But that light disappears fast. By the time we pass 200 meters, or about 650 feet, we're in the twilight zone. The pressure here is already intense, and the last rays of sunlight are fading out above us. This is where we meet the first of the deep ocean's strange inhabitants. Creatures like the deep-sea dragonfish, a predator with a jaw that can unhinge and teeth so long they don't even fit inside its own mouth. It uses bioluminescence, creating its own light to hunt in the growing darkness, a living lantern in a world of shadows. We keep going, past 1,000 meters, more than 3,000 feet. We've now reached the midnight zone. There is no light here at all. The pressure is immense, and the water is just above freezing. This is the home of the anglerfish, with its famous fleshy lure glowing in the blackness, a deadly invitation to its needle-sharp teeth. We might also see the barrelea fish, a creature with a completely transparent head, whose green, tubular eyes look straight up through its own skull to spot the silhouettes of prey far above. For years, we thought these were the masters of the deep. They're bizarre and fascinating, but they're familiar to us now. We thought we had a handle on things. But we kept pushing deeper. Past 4,000 meters, we enter the abyss. And past 6,000 meters, nearly 20,000 feet, we enter the Hadal Zone, named after Hades, the underworld. This is the realm of the deep-sea trenches. The pressure here is hundreds of times greater than at the surface, enough to crumple a military submarine like a soda can. And for a while, some of the sounds we heard were just as mysterious as the silence. In 2014, scientists detected a strange, metallic noise they nicknamed the bio-twang. It was a mystery for years, but by comparing the sound to known recordings, they eventually identified its source, a unique call made by a population of minke whales. It's a sound they seem to make only here, proving just how much this deep, dark environment shapes the life within it. But it's here, in the deepest part of the Challenger Deep, that the rules of biology didn't just bend. They seem to break entirely. Remarkable discoveries in the deep. Discovery number 1, the ethereal survivor. At an incredible depth of over 8,000 meters, or 26,000 feet, scientists recorded the Mariana snailfish. Calling it a fish almost feels misleading. This creature is practically translucent. Its body is a gelatinous, scaleless form that allows it to withstand the colossal pressure. You can see right through its skin to its internal organs. It moves slowly, like a gentle spectre gliding over the seafloor, propelled by its wing-like fins. Unlike the armored-looking predators above, the snailfish is a paradox. It looks incredibly fragile, yet it is the deepest living fish ever found, a master of an environment that should be unsurvivable. It's thriving in a place that would crush almost anything else. Scientists were stunned. Its body structure is unlike any other deep-sea fish they'd ever seen. And it's not alone. Expeditions have filmed swarms of other translucent creatures, sea cucumbers and shrimp-like amphipods, all perfectly adapted to this brutal world. These discoveries show that in the deepest dark, life doesn't always become monstrously armored. Sometimes it becomes fantastically delicate, shedding its substance to become one with the pressure. Discovery number 2, the invisible regulators. Maybe one of the most significant discoveries wasn't a creature you can see, but one you can't. In sediment samples hauled up from 8,900 meters, that's over 29,000 feet down, scientists found a virus. This isn't just any virus. Identified as VB_May_H4907, it's the deepest known bacteriophage ever isolated from the ocean. A bacteriophage is a virus that infects bacteria, and this one specifically targets bacteria from the genus Halomonas, which are common near deep-sea hydrothermal vents. Just think about that. In one of the most remote and hostile environments on the planet, there's a constant, invisible struggle happening on a microscopic level. While this virus belongs to a known order, it is so new and different that it's helping researchers understand the unique viral world of the deep ocean. It's a form of life that has evolved in extreme isolation. More importantly, it acts as a regulator for the entire ecosystem. These viruses control the bacterial populations, and those bacteria form the very foundation of the food web in the trench. Discovering VB_May_H4907 proves that even in the Challenger Deep, life isn't just surviving. It's part of a complex, interconnected system, influenced by invisible forces we're only just beginning to map out. Discovery number 3, the engine of life. For nearly all life on the surface, the sun is the source of all energy. Photosynthesis runs our world. But in the Mariana Trench, there is no sun. So what's powering this unique ecosystem? The answer is as fascinating as the creatures themselves. The Earth itself is bleeding energy. The entire food web here is built on a process called chemosynthesis. Instead of using sunlight, the base of the food chain is made of microbes that eat chemicals seeping from the ocean floor, compounds like methane and hydrogen sulfide, which are toxic to most surface life. While we've known about chemosynthesis since the 1970s, recent expeditions have found vast microbial mats spread across the seafloor at record-breaking depths, acting as living engines that turn these chemicals into life-sustaining energy. This is what supports everything else. The translucent sea cucumbers, the ethereal snailfish, the swarms of amphipods, they either feed on these microbial mats or on the other creatures that do. In 2025, Chinese submersibles discovered dense colonies of tube worms and clams thriving in total darkness at depths down to 9,500 meters, all clustered around these chemical seeps. It's a true, bustling food web where the sun has been replaced by the planet's own internal chemistry, a self-contained world running on a completely different set of rules. The broader implications: so why does a translucent fish and a microscopic virus found 7 miles down really matter? Because these discoveries don't just add a new page to our biology textbooks, they force us to rethink the whole story. For most of our history, we've assumed that complex life on this planet is ultimately solar-powered. We defined life through our own sun-drenched perspective. The Mariana Trench shows that this isn't the only way. Life can arise and flourish in extreme pressure and absolute darkness, powered by the raw geothermal and chemical energy of a planet. This has profound implications. If a complex ecosystem can exist in one of the most hostile environments on Earth, where else could it exist? Suddenly, the dark, icy oceans of moons like Jupiter's Europa or Saturn's Enceladus don't seem so far-fetched. Those places have the same key ingredients we find in the Mariana Trench: water, chemical energy seeping from a rocky core, and a complete lack of sunlight. The life of the Challenger Deep could be a blueprint for life elsewhere in the universe. We may have just found our first real-world model for an alien ecosystem, and it was hiding on our own planet the whole time. It just goes to show that we know fundamentally less about the world beneath our oceans than we do about the surface of Mars. More people have been to the moon than to the bottom of the Mariana Trench. This abyss is the largest and least explored habitat on Earth, and it's clear we've only just begun to scratch the surface. These discoveries are being made by institutions like the Schmidt Ocean Institute and NOAA, who use remotely operated vehicles to explore a world we can't visit ourselves. Every single dive has the potential to bring back something new, something that challenges our understanding of life. If you want to keep up with these incredible discoveries as they happen, make sure you subscribe and hit that notification bell. You won't want to miss what they find next. We looked to the bottom of the ocean expecting a void. Instead, we found a world teeming with remarkable survivors, regulated by ancient viruses, and powered by the planet's own chemical energy. The Mariana snailfish, the VB_MAY_H4907 virus, and the deep chemosynthetic ecosystems aren't just new discoveries. They're a powerful reminder that our definition of life has been a little too narrow. They prove that life doesn't just survive in extreme environments, it masters them. It adapts in ways that are both beautiful and scientifically astonishing. We once thought the Challenger Deep was the most desolate place on Earth. Now, we're faced with a much more awe-inspiring reality. The truly empty places might not even exist. Life is resilient and finds a way. And if these creatures can thrive in the one place we thought was lifeless, it leaves you with one final, exciting question: what else is hiding in the dark?